The next function for singly linked list is index of a function. Index of a function, when you provide the data, then it looks for the data in the list. If it finds it, then index of returns the position of the node where the data was found. If you don't find the data in the list, index of will return -1 because negative value cannot be a valid index range. So in this previous example, we have made a list named M where we have data in this order 5, 1, 7, 2 at index 0, 1, 2, 3. Then if that is the case, we could verify index of a function once it's completed. So index of 7 should be at 2. That's where we had 7. And then another index of 2 should be at 3. Similarly, index of 5 should be 0. So those are some few verification of index of a function. So let's add index of a function, integer return type, which is index of, and then data is provided. So parameter int is data type. Then list implementation, int class name, function name, data is provided. So let's see how we may implement the index of a function. So here is some situation. So in list object, front and tail pointer has a linked list. So here front node, tail node, and then each node is linked to its neighbor, and the very last one is null. Here position 0, 1, 2, 3 is there. So how do we find the position of the data? Or if we don't find the data, we should return -1. First, assert the condition. If the list is empty, then we cannot apply index of. There is no data, so the size should not be 0. It should not be empty. Then the idea of finding or implementing index of is that let's begin with the head. Let's begin with the head, and then let's keep moving to next one. Moving to next one means n is n link, then we are moving to the next one. So keep repeating this one, repeat this one until we find that n data is equal to the data we are looking for. So that's the basic idea, and then we just return the position. So here let's have a position initialized to 0. So what we do is as long as n is not null PTR, so n is, we are going to update n with a n by n arrow link, but if you keep updating that, we may end up the very end of the linked list, then n will be null pointer. So as long as n is not a null pointer, then let's compare the data in the node with the data we are looking for. Then break. So here each iteration we increment the position, and then we jump to the next node. So very first n is ahead, so at index 0 we look for the data. If there's not such data found, then we do increment position 1, and then n is updated by n link, then we move to the second node. We keep doing so. That in the end of the loop, if n is a null PTR, which means we've been through the list without finding the data we have reached at the end, then we couldn't find the data. Otherwise, the pause is holding the data. So that's the implementation of index of. Let's compile the program, run it. So the minimal verification is successfully done.